If the moment of inertia about the center of mass of a rigid body is known, the moment of inertia about any other axis of rotation can be calculated by using the parallel axis theorem. Often this simplifies mathematics. We'll present the theorem here without proof. I, the moment of inertia around any other axis of rotation, is equal to the moment of inertia about the center of mass plus m, which is the mass of the object, and d, which is the distance from the center of mass axis to your new axis of rotation. As always, we can never really understand a theorem until we actually use it. So we're going to apply it to the solid cylinder over here. It has a mass, capital M, and radius r. The moment of inertia when the cylinder is rotated about its center, that's this one right here. Here's your center of mass rotational axis. So that moment of inertia is 1/2 mr squared. Find the moment of inertia when it is rotated on an axis parallel to its central axis and at a distance r. So that's this picture here. So we have this whole cylinder rotating about this axis. So you can imagine a few seconds later, the cylinder, let's make sure it touches, will be over here, and then it will continue rotating. Use the parallel axis theorem. And here we go. Here's the parallel axis theorem. Here's the moment of inertia about the center of mass. And how far away is the new axis, this one here, from the center of mass axis? Well, r. So it's just m big R squared. You add the two and you get 3/2 mr squared. The only thing you have to be careful on here is, let's say they gave you the cylinder and instead of the radius they gave you a diameter, and let's say they called it, well, capital D. So in this case, for this D over here, you don't put in capital D. You're not interested in the entire distance. You're just interested in the distance between this rotational axis and the new one. And what would that be in this case? You would substitute in D over 2.